All right, so I get the point 1/1/2, so that's right here. So you know, at this point, you know what part of the graph looks like. So the part that's on the right side, you know what's happening to it. What's happening to this part of the graph right here? It gets closer and closer to the horizontal axis. Does it cross the horizontal? No. All right, and on this side, when you go like this, that's where it's going up rapidly. Okay? All right, so I just need a couple more points on this side. So give me another x value that's on this side. -1. 3 is not on this side, whoever said 3, but -1 is. So if I use -1, I get -2. I'm sorry, 2. If I use this one, that's 2 to the opposite of a -1. What's the opposite of a -1? +1, so that's just 2. So when x is -1, I get y is 2. Now if I use this one here instead, look at this now. If I use this one, that's 1/2 to the x power. What is x here? Now think about what we just talked about. How do I make that exponent positive? Take the reciprocal of 1/2. What's the reciprocal of 1/2? So that's 2 to the first, which is 2. And that's what we got here. All right, so I get the point -1, 2, which is here. And I need one more. Let's say -3. Someone mentioned -3. So if I let x be -3, it does not matter which of these you use. But remember, this was the original one. Many of you probably would not remember what this, writing this like this looks like. So if x is -3, I get 2 to the opposite of a -3. That's what that says. The opposite of x. If x is -3, I get the opposite of a -3. What's the opposite of a -3? So what's 2 to the third? 8. You knew it better be something bigger than 2, because the graph does this, right? So if all of a sudden you had something that did this, you know it can't be right, because that's not what an exponential function looks like. So -3/8 is here, and then all you do is just draw it, and you're done. All right, and notice the first thing I asked you was this. I said, is g of x, which equals 2 to the -x, is that an increasing or decreasing function? Some of you didn't know the answer. Some of you know which one to say. Some of you said increasing because you looked at the base, and the base was 2, and we did talk about the fact that if the base is bigger than 1, it's increasing. But whenever we talked about that, the exponent, the variable, had a positive coefficient. Here, what's this coefficient? Negative. So you need to rewrite this exponential so that way it has a positive exponent. So if I'm going to make this -x a positive x, I've got to take the reciprocal of the base. The reciprocal of the base is 2 is 1/2. And so now you see that 1/2 is less than 1, between 0 and 1. So it's decreasing. And you notice that it is decreasing. When I go from left to right, your graph is decreasing. Okay? All right, so one of the questions that you could be asked, the multiple choice question, is this. H of x equals 2/3 to the -2x plus 5. Okay? Is h of x increasing or decreasing? And let me go ahead and not put that plus 5, because then we have to do some factoring. So let me just do this. Let's just say negative 2x. It'll make it a lot easier for us. So is this an increasing or decreasing function? Huh? Why is it increasing? Because 2/3 is between 0 and 1. Because the negative exponent. I got to make sure before I can use the fact of the base helping me to determine whether it's increasing or decreasing, I've got to make that exponent positive. So if I want to rewrite this with a positive 2x, then I've got to do what to this base? Take the reciprocal. And so now notice that 3/2 is bigger than what number? 1. And so remember, the base is bigger than 1, greater than 1. It's an increasing function. So this is increasing. All right? Okay, now, let's look at this one. Let's go ahead and graph f of x, and I think we may have already done this one, but we'll do it again, graphing 3 to the x power. And then let's graph this one, 3 to the x plus 5. Notice that x plus 5 is in the numerator. If this was h of x equals 3 to the x plus 5 like this, see, those are two different things, right? What does that plus 5 do to 3 to the x? What kind of translation is that? It moves it up 5. Okay, good. So instead of your horizontal asymptote being y equals 0, it's going to be y equal what? 5. Right? So notice, though, this and this are not the same function. That x plus 5 is your exponent. Here, your exponent is just x. Okay? So that plus 5 on the outside here, that has to do with the vertical translation, either going up or going down. So let's kind of figure out what this does. So that's what we're going to look at. So let's graph 3 to the x first. So when I graph 3 to the x, what's the horizontal asymptote? Y equals 0. If I graph g of x, what's the horizontal asymptote? Y equals 0. So in both cases, the horizontal asymptote is the same, right? So here I'm going to graph f of x, which equals 3 to the x, and g of x, which equals 3 to the x plus 5. So in both cases, the horizontal asymptote is the same. So it's the x-axis, y equals 0. Now I'm going to ask you this. Is it in both cases, or maybe just one case, where the graph is above or below the horizontal? Is the graph above or below the horizontal asymptote? Huh? Above. Why isn't any of them below?
Because the base is greater.
No, it has nothing to do with that. It has to do with the reflection. If I have a reflection, then what must you see in front of that function? A negative. Do you see that negative right here? Do you see a negative right here? No. All right, so you got to remember, guys, if I asked you if the graph is above or below, that has to do with that reflection. If you don't see a reflection anywhere, then it's going to be above. The base greater than 1 has to do with the function increasing.
Okay. So then would it be correct to say the base is positive?
The base is always going to be positive.
Yeah, that's right.
Okay, remember we talked about exponentials? We said that b must be positive,
Okay.
and it cannot be what positive number? 1. All right, now, what is the y-intercept for this one?
One.
1. So if x is 0, I get 3 to the 0, which is 1. All right, let's find the y-intercept for this one. And maybe I should not have used this bigger one. Yeah, it's gonna be 3 to the 5th, which is not even in the plane. But we can still find it.
243.
All right, so your y-intercept if x is 0, you get 3. What's 0 plus 5?
5.
And 3 to the 5th, you said is 243?
Better have some big graph paper.
Yeah, so that's, so basically what's going to happen is this. For f of x, here was your y-intercept. For g of x, your y-intercept is way up here. And then it's increasing, so it's not gonna be a good one. So I'm gonna have to redo the function. But you see that it would do something like this way up there. So let me kind of make the function easier to graph. That's within hours. Let's do 3 to the x, and then let's do 3 to the x. Let's do minus 2. Okay, I think that'll be okay. 3 to the x minus 2. That x plus 5 made it too big because if x is 0, and if x is 0, what's the y value? 243. It's not even in the plane that we have to deal with. See, it went all the way up to, what, 19? Okay, so we had to change it. But we can still keep f of x. All right, so we found the horizontal asymptote to be y equals 0 in both cases. We found the y-intercept for this one to be y-intercept to be 1, right? Over here, if to find the y-intercept, I let x be what?
0.
So I get 3 to the negative second power. Use your calculator if you need to.
1/9.
Which is 1/9. So 0, 1/9. Now watch this. 0, 1/9 is here. 0, 1/9 is right here. It's very close to the y-axis. Right here. All right? All right, so let's go ahead and finish graphing 3 to the x, and then we'll come back to this one. Okay, so if x is, let's say, 1, I get 3 to the first power, which is what?
3.
3. So I get 1, 3, which is here. Oops, sorry, here. So you know what this side does. This side does this. It gets closer and closer to the horizontal asymptote. And on this side, it rises rapidly. Give me one more value for x. 2. So if x is 2, I get 3 squared, which is 9. So I get 2, 9, which is here. All right, now what is it that I've just graphed? What is this graph? No, but what is it? What is that function? F of x equal 3 to the x. All right, what is the domain on both of these? Yeah, in both cases, the domain, and remember, for all exponential functions, it's always going to be negative infinity because I can plug any number for x and I'll get a y value back. What's the range? What's the range?
1, 2.
He says 1 to infinity. Is he correct or not?
No.
No, he's not correct. What is the range? 0 to infinity. It's a horizontal asymptote. Did you need the graph in order to tell me what the range is? Did you need to look at the graph in order to tell me that? No. All you need to know was what the horizontal asymptote is, which is y equals 0, right? And then you need to know, is the graph above or below? Is there a reflection? So the graph is where? Above. So it's from 0 to what? Infinity. All right, now let's graph g of x. So I found the y-intercept, that's here. Now, let's go ahead and, remember this is no longer g of x. G of x is 3 to the x minus 2, is that right? Yeah. All right, so give me another value for x, for this one, 3 to the x minus 2. You said 1? So if x is 1, I get 3 to the 1 minus 2, right? Which is 3 to the negative 1, which I really don't want you using a calculator on that part. I need you to recognize that 3 to negative 1. If I'm going to make that 1 positive, I got to take the reciprocal of the 3. So the reciprocal of 3 is what?
1/3.
So it becomes 1/3 to the first power, which is 1/3. Now, if you use your calculator, it's no big deal. Use your calculator if you need to. You'd say 3 to negative 1, you'll get a decimal point 33333. You just got to convert that back to a fraction. So 1/1/3, look at this. 1/1/3 is, this was what, 1/9? 0/9? So 1/1/3 is right here. See it? Let's do 2. Watch what happens. Let's do 2. If x is 2, I get 3 to the 2 minus 2, which is 3 to the what? 0, which is what? 1. So I get, what did I say, 2? I get 2, 1, which is here. If x is 3, I get 3 to the 3 minus 2, which is 3 to the first, which is 3. So I get 3, 3. So look at what happens here. This part goes like this, and this goes towards the horizontal without crossing it. Now, this is the graph of g of x. In both cases, you see a 3 to the x, don't you? Yes or no? Okay. If this was h of x, which equals 3 to the x minus 2 instead, minus 2 on the outside, then that would be what kind of translation for the 3 to the x? What would this graph look like? If I take 3 to the x and do what to it? I would get this. What would I do?
Oh, it would shift down.
Shift it down 2. So the horizontal asymptote would be y equal negative 2. But that's not what this is. So then I'm going to ask you, what do you think that minus 2, if it's in the exponent, what do you think that does? Look at your graph. It's a horizontal translation. Instead of a vertical translation, it's a what? Horizontal. Do you see that 3dx, you moved it which way? To the right. Now look, I'm counting. Watch. 1, 2. 1, 2. You can't see it. It's really supposed to be, all this space right here is supposed to be 2 units this way. So all these are supposed to be how many units? 2. All right. So if it's in the exponent, that number, then it's what kind of translation? Horizontal. You're going to learn more about translations in another section. It's not so much here. Basically here you just can do a t-table. But I just wanted to introduce the idea of translation. So if it's on the outside, is what kind of translation? Vertical. Those are easy for students if it's on the outside. If it's in the exponent, it's more difficult for students because of this. Now listen carefully. Intuitively, if you see x minus 2, you see that minus 2, you think 2 units to the left, right? 2 units to the left. But really what happened? You went 2 units which way? To the right. So intuitively, it's just the opposite of what you would think if it's in the exponent. All right, we're going to talk more about that horizontal. The horizontal translation gets students. We're going to talk more about that in another section. But all you had to do here was just use a t-table, just like we did. All right, so real quickly, let's try this one. What if you had g of x equal I think I have enough, 4 to the x minus 3. 4 to the x minus 3. Now, what is the horizontal asymptote? Y equals 0. Don't confuse this with this. That's two different functions. What's the horizontal asymptote here? Y equal negative 3. That negative 3 is in the exponent. So that's going to be what kind of translation? Horizontal, not vertical. Horizontal. All right, so what's the horizontal asymptote? Y equals 0. Because isn't this right here the same thing as plus 0? So that's why it's y equals 0, because this is 0. What is a y-intercept? Okay. Let y be 0. So I get 4 to 0 minus 3. What's 0 minus 3? So on your calculator, what's 4 to the negative third power? Or a fraction is 1 divided by 64. So 0, 1 divided by 64. Here's a horizontal asymptote. 0, 1/64 is very close to the origin. Right here. It should be lower than that, but that's as best I can do. See right here? Watch. So this should be 0, 1/64. Should be way close to the x-axis. Now give me another value for x. Give me another value for x. 3, okay. 3 would be fine to use, because what's 3 minus 3? So you get 4 to the 3 minus 3, which is 4 to the 0, which is 1. So you get the point 3, 1, which is here. Now, the fact that I know this, means that this part of the graph gets closer and closer to the horizontal asymptote, and this part rises rapidly. But you knew that this was what kind of function, increasing or decreasing? Increasing, because the exponent, the variable, has a positive coefficient, and the base is what kind of number? A number bigger than 1. So you know it had to be increasing. So give me one more number for x. Let's do 4. If x is 4, I get 4 to the 4 minus 3. What's 4 minus 3? So 4 to the first is 4. So I get 4, 4, which is here. Oops. All right, so there's your graph. That's all you had to do. It's just using a t-table. Notice I didn't talk about, I didn't use the idea of transformations here, but I'm just trying to introduce that term before we get into that section that really deals with it. All right, so let's see. What is the range? What's the range? Say it again. 0 to infinity, because it's above the horizontal. We said the domain, I didn't write it down, we said the domain was all real numbers, negative infinity to infinity. We found the horizontal asymptote, we found the y-intercept, and we said is what kind of function? Decreasing, increasing? Increasing. Okay. All right. Now, look at this